Right now, as you listen to this, the planet under your feet is slowing down. Not metaphorically, measurably. Every 100 years, the day gets longer by a little under 2/1000ths of a second. The moon is dragging on our oceans, stealing a sliver of the Earth's spin with every tide, and flinging itself a few centimeters farther away each year to pay for it. 2/1000ths of a second per century sounds like nothing. It is nothing to you. But the Earth has been doing this for 4.5 billion years, and it does not stop. So run it forward. Don't change the physics. Don't invent anything. Just let the clock keep ticking, the way it already is, the way it has to. Eventually, the day is 48 hours long. This is the file on what that does to a human body, and the part nobody tells you is that the planet survives it just fine. It's us that doesn't. This is the case. Here's what we know. Start with the thing that's actually true, because everything that follows is built on it, and none of it is invented. The Earth spins once roughly every 24 hours. It didn't always. When the first complex life was forming in the oceans, a day was closer to 21 hours. Go back further, to around 1.5 billion years ago, and the day was about 18 or 19 hours long. We know this not from a guess, but from rocks, tidal rhythmites, layered sediment that recorded the rhythm of ancient tides, the way tree rings record years. You can read the length of a prehistoric day out of stone. The slowing is caused by the moon. The moon's gravity pulls hardest on the side of Earth facing it, raising a bulge of ocean. But the Earth spins faster than the moon orbits, so that bulge gets dragged slightly ahead of the moon. The water is, in effect, always running a little late, and that misplaced bulge tugs back on the moon, handing it energy, while friction between the moving water and the sea floor quietly bleeds the spin out of the planet. The number, as best we can measure it, is about 1.7 to 2.3 milliseconds added to the day every century. Here is the first uncomfortable thing. That rate is not fixed. For more than 1 billion years, from roughly 2 billion years ago to 600 million years ago, the slowing simply stopped. The day got stuck at about 19.5 hours and stayed there. The reason, according to work published in the last few years, is that the sun's heat sets up a second tide in the atmosphere, a thermal tide, that pushes the Earth's spin in the opposite direction. For over 1 billion years, the solar tide and the lunar tide canceled almost perfectly, and the planet's day froze in place. Then they fell out of sync, and the slowing resumed. That's the process we're living in now. So we can't say exactly when the 48-hour day arrives. The honest answer, and this matters because most people who tell this story pretend they know, is that at the current rate, doubling the day would take something on the order of 100 to 200 billion years, which is a problem because the sun will have died long before then. In about 5 billion years, it will swell into a red giant and very likely swallow the Earth whole. So, let me be precise about what this file actually is. The 48-hour day is not a prediction. The Earth will almost certainly never reach it on its own. It is a controlled experiment. We are taking one thing that is genuinely, measurably happening, the planet's spin slowing under the moon's pull, and we are following it forward, honestly, past the point where the sun interferes to ask a question nobody asks. Not what happens to the Earth. The Earth is fine. A slower planet is still a planet. The question is, what happens to the body of an animal that was assembled cell by cell, gene by gene, over hundreds of millions of years, to run on a 24-hour cycle, when the day it was built for is gone. That's the exhibit. Let's open it. You have a clock inside you. Not a metaphor, a physical structure, about 20,000 neurons sitting just above where your optic nerves cross, called the suprachiasmatic nucleus. It is the master pacemaker. It does not need the sun to keep time. Put a person in a sealed room with no windows, no clocks, no hint of day or night, and that cluster of neurons keeps ticking on its own. And here's the detail that the entire rest of this story hangs on. It does not tick at 24 hours. When researchers measure the true intrinsic period of the human clock, in the lab, under careful conditions designed to strip away every outside time cue, the average comes out to about 24 hours and 11 minutes. Slightly long, most people, left to their own internal rhythm, would drift a few minutes later every single day. So, how do you stay on a 24-hour schedule when your clock runs slow? Light. Specifically, morning light. Every day, the sunrise nudges your clock back into line, resetting that 11-minute drift before it can accumulate. The technical word is entrainment. Your body does not generate the 24-hour day. It is dragged onto it every morning by the light. Which raises the obvious question: how far can you drag it? This is where the science gets genuinely unsettling, and where I want to be careful, because we actually know the answer, and the answer is small. In a set of experiments at Harvard, researchers took healthy people and slowly stretched their days, not to 48 hours, nothing that dramatic. They tried 23.5 hours. They tried 24.6 hours. A difference of about 36 minutes from the normal day in either direction. Under dim light, about the brightness of candlelight, which is closer to how most of us actually live indoors, the human clock could not keep up. People on the 24.6-hour day did not entrain. Their internal rhythm came unstuck from their schedule and began to free run, drifting away on its own. Let that land. 36 minutes. Add a little over half an hour to the day, dim the lights to ordinary indoor levels, and the master clock in the human brain loses its grip. Now, we're not talking about 36 minutes. We're talking about doubling the day. 24 extra hours. There is no version of the human circadian system that entrains to that. None. It is so far outside the range that the experiments to test it have never needed to be run. The boundary was found at half an hour. A 48-hour day is not a harder version of jet lag. It is a different category of problem, so follow it forward. Honestly, step by step. A person living on a 48-hour day would experience a single block of daylight, roughly 24 hours long, followed by a single block of darkness, roughly 24 hours long, one sunrise, then a full day and night's worth of unbroken sun, then one sunset, and an equally long darkness. Their body, meanwhile, is still trying to run its old rhythm. Core body temperature still wants to rise and fall on its near 24-hour cycle. Melatonin, the hormone that tells the brain it's night, still wants to surge roughly every 24 hours. Cortisol, the hormone that ramps you up to wake, still wants to peak on its own schedule. But the world outside is now keeping time at half their pace. So, for the first stretch of the long day, body and sky agree. It's morning, the sun is up, you're awake. Good. But your internal clock keeps moving while the sun does not. About 12 hours in, your body insists it's night. It dumps melatonin into your blood. Your core temperature drops. Every signal you have says sleep, and the sun is directly overhead. This is not discomfort. This is the precise physiological state we induce on purpose in the worst kind of shift work. The state we have linked, in study after study, to a measurably higher risk of metabolic disease, of mood disorders, of certain cancers. We have a name for the milder, weekend version of it: social jet lag, the grogginess from sleeping in on Saturday and dragging yourself up Monday. That's a desync of maybe an hour or two. On a 48-hour day, your body and your planet would be 12 hours out of phase, and then back in phase, and then 12 hours out again, over and over, with no morning light arriving at the right time to ever fix it. The reset signal that's supposed to come at dawn arrives a full day late. The thing that keeps you synchronized is gone, and there is no replacing it, because the sun simply will not rise when your body needs it to. Here's the original number I worked out for this file, and I want to show the arithmetic so you can check it. A human life is about 4 billion seconds, round numbers, 80 years, give or take. On our current 24-hour day, that's a little over 29,000 sunrises in an entire human life. On a 48-hour day, the same lifespan gives you fewer than 15,000. You would see half as many dawns in your whole life, not because you live shorter, but because the dawns come half as often. The single most powerful signal your biology uses to anchor itself in time would arrive, across your entire existence, half as many times as it was designed to. Now, the honest detour, because this is the part most versions of this story skip, and it's the part that keeps the file open. Maybe none of that matters. Maybe I'm wrong. Here's the case against everything I just said. Evolution is not frozen. The 48-hour day, if it ever came, would not arrive overnight. It would creep in over tens of billions of years, the day lengthening by fractions of a second per generation. And life adapts to slow pressure. The exact same moon that's slowing us down today is the reason the day was 18 hours long when early life appeared, and that life did just fine. The creatures of an 18-hour world had clocks tuned to 18 hours. There is no law of biology that says the period has to be 24. It's 24 because that's the day we happen to have. So, a species evolving across the long slowdown might simply retune. Its master clock might stretch. Some animals already run on stranger schedules. There are mammals with circadian periods well off 24 hours, and creatures in the deep sea and the polar regions that have nearly abandoned the daily cycle altogether, because where they live, it barely exists. But here is the residue, the thing that adaptation can't fully explain away. The human clock didn't drift to 24 hours, 11 minutes by accident. That value is wired deep into the genes that build the clock proteins, into the structure of the suprachiasmatic nucleus itself, into a network so fundamental that nearly every cell in your body runs its own copy of it. Your liver has a clock. Your skin has a clock. They are all slaved to the one above your eyes, and they are all expecting the same 24-hour beat. You cannot retune that with willpower, or with a lifetime, or with 100 lifetimes. You would have to rebuild the genome, and we genuinely do not know. This is an open question, not a settled one, whether a clock that precise, that distributed, that ancient, could be rewritten by evolution faster than the environment that anchored it slipped away. We don't know if the biology could chase the planet, or whether, somewhere in those billions of years, the animal and the day it lived on would quietly lose each other for good. That's the edge of what we know. I'm going to sit in it rather than pretend past it. So, here's where the file closes. The 48-hour day will almost certainly never come. The sun will end us first. This was a thought experiment. One real variable, the slowing spin, followed forward without cheating, but it leaves something behind. And it's not about the far future at all, because you don't have to wait 100 billion years to meet this. You carry the experiment in your skull right now, the clock that runs 11 minutes slow, the reset that has to come from the morning, the narrow, fragile window, half an hour, no more, inside which your entire sense of time can be dragged along by the light, and outside which it simply comes loose and drifts. We think of ourselves as living on the earth, standing on it, separate from it. But you're not separate from the spin. You are tuned to it, down in the cells, in a frequency you did not choose and cannot feel. The planet turns, and something in you turns with it. And the only reason you've never noticed is that the two of you have never once fallen out of step. The day is getting longer, slowly. Right now, by a sliver, every century. Not enough to matter in your lifetime, not enough to matter in your civilizations, but the clock in your head is already 11 minutes behind. And every single morning of your life, without your permission and without your awareness, the sunrise reaches in and sets it straight. Whoever's listening to this, the spin that keeps you on time is, very slowly, winding down. The file stays open.